Hello everyone, I'm Vivek from K4 Metrics and we support SmartUQ in India. In part 3 of this series, we covered how to load the CAE data into SmartUQ, how to create the surrogate model, how to check its accuracy, and how to add data points to improve the accuracy of the surrogate model. Continuing that, in this video, I'll be using that surrogate model and I'll be covering these four studies. That is, first is the prediction of new simulation outputs for new set of input parameters. Second is the optimization, and third would be sensitivity analysis, and fourth is the uncertainty propagation. So with this, I'll just shift to SmartUQ. And as I mentioned in the previous video, I needed about 21 slices of data to get the accuracy that I wanted. And using this X and Y matrix, I have created the surrogate model here. So before just going back to the studies which I showed in this slide, I would like to just cover this surface and multi-view. So first I'll go to surface. So this gives you different types of plots, and so this is a 3D plot, and you can see that these two axes depict the input parameters, angle of attack and free stream pressure. The z-axis depict the output parameter. So you can change the parameters here, and what I would like to also show is something called this display variance. So this gives you the confidence interval in the surrogate model. That is, you can see two gray surfaces that has come above and below the plot. So this gives the upper and lower bounds for the output parameter that is predicted by the surrogate model. So I'll be covering more on the confidence interval in a separate video that we are planning to do. Coming to the multi-view, this is an interactive plot that shows the relationship between the input and output parameters. So if I move this line here, you can see that there are no variations. And the line here is flat. So I can determine from this that the influence of free stream pressure on the output values is almost negligible. Uh, if I move the angle of attack lines, you can see that there are a lot of variations. Similarly, the Mach number. So this way I can determine the relationship between the input and output parameters. Another advantage of multi-view is that it will also give you the probability distribution function here. So currently it is set for uniform. I'll just change it to normal distribution, and this gives you the histogram directly here. And I'll be covering more on this when I talk about the uncertainty propagation. So here also the display variance is available, that is the confidence interval. So you can see the upper and lower bounds here. Again, when I do the separate video on this, I'll be covering more on this. So with this, I'll just start the four studies which I mentioned in this slide. The first would be the prediction of new simulation outputs. So before going for prediction, what I'll do is I will load the new input parameters and click on open. So you can see that I have loaded my input parameters for 10 simulation runs. So I'll go back to predict and I'll select the new input for prediction and I'll just click on submit. So this will give me the CDCL value for all these certain simulation input parameters, and you can see that I got this within 2 seconds. So this saves me the time of doing these 10 simulation runs in a CA solver, which could take hours or even in some cases days together. Now let's compare the accuracy of the prediction from SmartUQ. So for this, I have opened this in Excel sheet. So these are the values that I've got from SmartUQ, that is from the prediction. And what I've also done is I've taken the same input parameters to SU2, that is the CA solver, and I have done the simulation as well. And these are the outputs from the simulation software. Now, if we compare the first simulation run, you can see that the values are 0.107 and 0.184, and here it's 0.107 and 0.184. And the second simulation run, it's 0.195 and 0.668. Here it's 0.194 and 0.665. So you can see that the Prediction from SmartUQ is highly accurate when you compare it with the actual output from the simulation run. So here is a comparison with a chart. So the first chart shows the prediction from SmartUQ, and second shows the actual output from the SU2 values. So you can see that you get highly accurate results from SmartUQ for your simulation prediction, and you are saving hours and even days together of resources. So with this, I'll just get back to SmartUQ, and the next thing I'll be showing here is the optimization. So again, this will be using the same surrogate model here, and I have to give the specific targets for output parameters. For coefficient of drag, I'll give it as minimize it as much as possible. For coefficient of lift, I'll specify a target value that I would like to have. That is, for example, 1, and I'll just click on submit. So this will give me specific input parameters. Like as you can see here, it has given me specific input parameters to achieve the target of minimized coefficient of drag, and similarly specific input parameters to achieve the coefficient of lift as 1. So you can take these input parameters to your simulation software to perform the simulation. The next thing I'll be showing is the sensitivity analysis. So this is a great way to determine which input parameters influence the output the most. So if I go back here, so you can see that the free stream pressure, as I mentioned in the multi-view also, is not influencing the output at all. And the angle of attack is the one that is influencing the most. The second is the Mach number. Now, if you're dealing with 15, 20, 25 input parameters, so sensitivity analysis is a great way to determine which input parameters drive the output the most, and you can focus on only on those input parameters. The last thing I wanted to show is the uncertainty propagation. So propagation of uncertainty helps you to determine whether system outputs, that is in this case simulation outputs, will meet requirements given the variation in the input values. By default, it is set to uniform distribution, so I'll just change it to normal. Um, I'll be doing the same thing for all the input parameters here. The next step would be giving the number of simulation runs. So here you have to specify the number of simulation runs, and this uses the Monte Carlo method. The Monte Carlo method randomly samples the data points in your design space within the input and output input bounds that you would have given, and uncertainty propagation requires a large number of simulations to be performed. For example, I have three input parameters, so I'll be giving as 3000 simulation runs. I can even give 30,000 as well. So once I click on submit, so you can see that within a matter of seconds, that is within 2 seconds, SmartUQ performed 3000 simulation runs using the surrogate model, and it gave the uncertainty propagation output. So here this is a histogram, and the x-axis shows the output value. You can change it from here, and here you can select the number of bins for your histogram. By default it will be 50. Now the percentage here it is showing as 100% because it is showing the complete bounds for the output value, that is minus 0.28 to 1.6. So let's say if I'm interested to look at the bounds between 0 and 1. So here you can see the bounds that I have just specified now, and SmartUP is saying that out of those 3000 simulations, 94.4% of simulation output value lie between 0 and 1 here. So this gives you a way to boost your confidence in your design output, that is the output bounds, and you also increase your confidence in the input parameters that we have taken here. And this each bin gives you specific details. So for example, if I hover my mouse on this bin, so this bin shows the detail for 204 simulations, and these 204 simulations lie between 0.43 and 0.52. Similarly, if I go hover my mouse on this bin, so it shows 323 simulation lie between 0.34 and 0.43. And if I go all the way to the highest bin, so this gives me detail about that 684 simulation runs lie between 0.16 and 0.25. So again, this gives you a great way to boost confidence in your design output. And if you want to view the points that SmartUQ has evaluated, so you can go to evaluated points. So here you can find all the cheat-ups and simulation data, that is the input parameters and the output parameter that have been generated. So with this, let me just get back to the presentation. So this ends the series on continuous response emulator. We'll be doing more videos on other types of emulators and the other features available in SmartEQ. Now, to just summarize the series, we started with the agenda of reducing the number of simulation runs. And so these are the three parameters that drive the agenda the most. So the first is the DOE. So as we saw in the first video, SmartEQ gives you various space filling DOE methods that will sample the points across your design space, leading to reducing the number of simulation runs. Second is the prediction of new simulation outputs using the surrogate model. And as you can see that the accuracy is also pretty high. So this saves you hours and days together of time and resources. The third is the uncertainty propagation, as this gives you the confidence in your design and your simulation runs. SmartEQ has also a lot of webinars in their website. There are a lot of upcoming webinars. You can check them out. You can register for them. For the past webinars also, you can view the recording of it. So I'll leave this link in the description so you can check this out. So if you have any questions on what I've shown in this specific video or on this series, you can drop a comment down or you can reach out to us at support@kfometrics.com.